Today we'll speak normal incidence of electromagnetic wave or uniform plane wave or electromagnetic wave again. See, we have two types of incidence. One is a normal incidence like this on some medium, and one more is oblique incidence. Oblique incidence we won't have for syllabus, whereas normal incidence is there for the syllabus. You know what do you mean by normal incidence? It is a vertical incidence like this. This is a medium. This would be our normal incidence, what we call. See, very interesting. Definitely one question will be there. Either problem or theory will be there. 100% one question will be there in your internal as well as in external examination. Just understand this. Up to this you can see.
Yes.
Yes. Okay. See what I do. Let us take. This is the boundary between two medium. This is. Please concentrate. Medium 1 and medium 2. Okay. This line is a boundary between medium 1 and medium 2. Let it be the medium 1 and medium 2 a general medium scale. Again, shall I assume the wave is traveling in x direction? That is okay. So what I do? Let us take. This is the wave traveling in. I'll take this as x direction. Okay. Then E will be in, if this is x, y, and h will be in z direction. Then I'll take this is E, I of x. I'm writing only in phasor form, not time domain. It is in phasor form. Is it or not? Ei of x, not Ei of t comma x. For Ei of t comma x, you need to take real value of this. Yes or no? Then this is incident I am taking. Some part of the incident will be reflected back, and some part will be transmitted. Yes or no? See, let us see this. Shall I write first reflected? And see, when E is in this direction, what will be the direction of H? E is in Y direction. What will be the direction of H? This I will write dot. Dot indicates it's coming out from a bird. Are you getting? This is the dot. I can't draw this H because it is perpendicular to bird. Dot indicates coming out from bird. This is the direction of H. That will give HI. This will give HI. No, part of this will be reflected back. Part of this will be transmitted. No, concentrate. In which direction it is traveling? Reflected? Minus x. Okay. Then, just even mathematically as well as through figures we will see here both. Earlier, x, E, and H. That is gone. Incident. Then what happened? It's turned like this. Direction change हो गया. Then what about the direction of E? It remains same. What about the direction of H? Minus Z. Yes, sir. Are you getting? See, it went like this. This is H, this is E, direction of H, this is the direction of E, and this is the direction of propagation. It went, then turned back. This is reflected. This is the direction of propagation, minus X, plus Y, minus Z. Just I'll draw this, and this will be something I'll write as ER reflected of X, then minus X, and what will be the direction of H? I'll write across. cross indicates entering into board or going into board. Okay, now? Is it clear? This is in medium 1. Incident as well as reflected. Some part of the incident will be transmitted or not. Just I'll write that here. The amplitude of this, the amplitude of this, the amplitude of this won't be same. Won't be same. Because incident is equal to reflected plus transmitted. Yes or no? That's what we want to find. Here I am putting same amplitude, but amplitude won't remain same. Then see. This is the direction of propagation, direction of H, direction of E. It's went here, and know what happened? The medium has been changed. The medium change to change in a velocity, there is a possibility. But direction of propagation still remains same. Direction of E remains same. Direction of H, but it may get attenuated. The amplitude may change, the velocity may change, but the direction remains same. Hence, this is your E P of X. And what about the direction of H? Still it is dot only now. This is your H P of X. Are you getting? Is it clear? This is incident. Write down this is HI. Yes, it is there already. HI, HT, HR, or else in terms of EI, ET, EM. No, we made this through figure by showing like this side. No, let us make with the help of mathematics also what we have. AK, E, AH. Yes or no? In this case, I took AX. What is this? AY. Now coming to this figure, the wave is traveling in. Then still this remained AY. AE remained in Y direction. Then what about H? That's all. Yes or no? This is what it is. Whereas for that, same as this. No, shall we see everything? Shall we write mathematical equation for all these things? Sure. See, the phasor form of incident wave. Take down. The phasor form of incident wave. E I of X. See, I wrote now e to the power some gamma. That is phasor form. E to the power t gamma x will be a time domain. This is equal to E I M. This is magnitude of incident electric field. E to the power minus gamma 1 x. Why I write gamma 1 for incident? Because incident wave is in which medium? Medium 1 or medium 2? Medium 1. That's why I write gamma 1. And what is the direction of this? A y. E is in y direction. We are propagating in x direction. How to obtain time domain of this? मुझे नहीं चाहिए at present. Take multiply this with e to the power j omega t. Take its real value. You can obtain time domain. Yes or no? Then what about h I of x? What about h This is incident magnetic field. What is this? It is equal to e to the power gamma 1x a, and this you can write it as h r m e to the power gamma 1x is. This you take on phasor form of incident wave, and similarly phasor form of reflected wave. How you are going to write reflected wave? E R of x is equal to this reflected wave. How you are going to define? E Rm, that is amplitude of reflect. Please concentrate. E to the power, plus gamma 1 or minus gamma 1? Very good. Appreciable. Happy. I am happy. Because the wave is traveling in the and what about the direction of E? Still direction of E remains. That is A, Y. Same as this. That's all. Then what about H R of x? E Rm by beta 1 e power of gamma 1 x. What is the direction of this? Minus AZ. This I'll write it as minus H Rm e to the power gamma 1 x AZ. Okay, now? Is it clear? Then phasor form of transmitted wave. E T of x E Tm e to the power this thing minus gamma 2 x. Why gamma 2? Because transmitted wave is in medium 2 and A. Then what about Ht of x? Etm by eta 2. Why eta 2? Because it is in the medium 2. E to the power minus gamma 2x A, and this can be written as H Tm e to the power minus gamma 2x A. Fine. Now take down some point here. When wave is incident, when electromagnetic wave is incident on the boundary between two medium, when electromagnetic wave is incident on the boundary between two medium, part of it will be reflected and part of it will be transmitted. Okay. We have written this sentence in the beginning, but at end also we can. No, what will be known to me? Call it as equation number 1, 2, 3, 4, 5, and 6. See, what is known to me? Amplitude of incident electric field. I will be knowing the amplitude of this. The amplitude of this and amplitude of this will be unknown to me. Are you getting? How much is incident I know, but how much is transmitted, how much is reflected depends upon the medium. 1 and 2. That we need to determine. See, we'll be knowing the amplitude of, see, if I know this, can I find HIM or not? If I know this will be known, but unknown are ERM and ATM. Unknown are ERM and ATM. That has to be found. If I know the amplitude, if I know the amplitude of incident will be known. That is EIM will be known, or EIM by eta 1 will be known. That's why I said amplitude of incident wave. I didn't say electric or magnetic. It may be electric or magnetic. Amplitude of incident wave will be known. We need to find amplitude of transmitted wave. That is ERM and ATM. Okay? Two unknowns are there to me. Then only I can write the amplitude there. For this, what is the amplitude? For this, what is the amplitude? I can write. One amplitude is known. I need to find two unknowns. That is ATM and EIM. But still, I didn't consider what is this medium 1 and medium 2. They are the general mediums at present. No. Shall I rub this? No, what I want to use is, this is a boundary between two mediums. See, I want to use a boundary condition. The boundary exists at x is equal to 0. Here I took x is equal to 0. And there is a plane. Which plane between boundary? Y and Z. This is x. Are you getting? This is x. What is this and what is this? YZ is a plane between these two boundaries. At boundary x is equal to 0. See, to take down, this is x is equal to 0. To find ERM and ATM, we use two boundary conditions. Full stop. The boundary exists at x is equal to, x equal to 0. Yes or no? That. Boundary condition 1. Boundary condition 1. See, we studied electric field and magnetic field boundary conditions in second unit and third unit. See, you take electric or magnetic field, whether they are tangential component to boundary or normal component to boundary. Normal or tangential component for boundary. This is a boundary is ahead. The wave is propagating like this, then E or H will be like this. No, this component is tangential or E is like this, H is like this. Tell me whether this is a tangential component or normal component. This is a tangential component for boundary. Is it or not? No, boundary 1. Tangential component of electric field at the boundary between medium 1 and medium 2 is continuous or discrete. No, direction. I am not talking of direction here. Whether continuous is this electric field is equal to this electric field. That is ET1 equal to ET2. If not, ET1 divided by something is equal to ET2. We saw. See, you refer that boundary condition, the tangential component of electric field is continuous. Now similarly, boundary condition 2, this is your H. H is here like this, H is here like this. Means tangential, second boundary condition is tangential component of magnetic field is also continuous. Means whatever the magnetic field is here is equal to magnetic field of this. How? Because of the boundary conditions which we studied. Boundary condition. At boundary between two medium, at boundary x is equal to 0, at boundary x is equal to 0, between two medium, the tangential component of electric field, is continuous. No, then what you can write? From this equation, from equation 1, 3, 5. From equation 1, 3, 5. Put x is equal to 0. What is the electric field in medium 1? EIM. If I put x is equal to 0, this will become EIM. Then, what is another even magnetic field from this also I'll get? Plus ERM, because tangential component of electric field in this medium is equal to tangential component of electric field in this medium. This and this, tangential component of this and tangential component of this is equal to, from this, this is equation number 7. Is it clear? Is it clear to all or not? Yes or no? Just the tangential component of these two is equal to tangential component of this. These two means I need to add. No, similarly boundary condition 2. Take down. At boundary x is equal to 0. At boundary x is equal to 0. The tangential component of magnetic field intensity is continuous. Continuous means, shall I write this? What you write continuous? You see, from equation 2, 4 and 6. At x is equal to 0. What you can write? EIM by, see this, eta 1. This is HIM, yes or no? Is EIM by eta 1. Then what about this? Minus ERM by eta 1. 5 minus, is it clear? Is equal to ETM by eta. Call it as equation number 8. Is it clear? This is a magnetic field component. This plus this. Why it is minus? Because the direction of H is minus. This is till now we consider medium 1 and medium 2 as a general. Later, after result, I will consider their specific mediums. No, I will define. Let us define reflection coefficient. I'll denote it by like this. How you are going to define reflection coefficient? How? Reflection, see, coefficient is always less than 1. It is a ratio of see, if it is a ratio of incident by reflected means reflected is always lesser than incident, then it is more than 1. It should not be like that. It is a ratio of reflected by incident. It is a ratio of amplitude of, where is that? Amplitude of reflected wave Take out. Amplitude of reflected wave divided by amplitude of incident wave. This is, what is the amplitude? ERM by EI. Then similarly, transmission coefficient, denoted by T. How you are going to define this T? Transmission coefficient. Amplitude of transmitted wave divided by incident wave. This is ETM divided by EIM. Okay, now? Have you taken this? See, my idea, my target is to find ERM and ETM. That's all. Why we are doing this analysis? I will be knowing EIM. I need to find ERM and ETM. Is it okay? Shall I proceed? I'll rub this side because I need this equation. Shall I rub this? Called as equation 7 and equation 8. Now what I do? Divide equation 7 by EIM. Myself, you don't rub here, right? Just I'll do divided by EIM. Okay. Then this will be 1 plus, what is this? Let it be like this. I know this is a reflection coefficient and this is a transmission. Let it be, because I know the definition of this. Then similarly, divide equation 8 by EI. Even this also I will divide by EI. Okay? Shall I have this? Because these definitions will be known to me. Okay. Check it. This will be 1 and this is 1 by eta 1. See, and this I'll write as ETM by EIM is equal to eta 2 by eta 1 minus eta 2 by eta 1 ERM EI. Call it as equation number 9 and this as 10. You see 9 and 10. RHS is same. If you see 9 and 10, RHS is same or not?
Yes.
Can you equate them? Equate 9 and 10. What do you get? Eta 2, eta 1 minus eta 2, eta 1 ERM. Shall I write this ERM by EIM as? This has what? The reflection coefficient. You can write there itself, not an issue. Why I am writing here? Because I need a space. space constraint is there for me on the board. That's why I am using a notation. This is equal to 1 plus. See, my intention is to find reflection coefficient and transmission coefficient here. No, why I equated? Because this also consists transmission coefficient, reflection coefficient, and this also consists reflection coefficient. That's why I equated. Then this, you can write this equation as, you make the reflection coefficient one side. This I'll get this side. Better I'll write here itself. If this comes this side, it will be. No, what I do, this I'll move this side. Theta 2, theta 1 minus 1 is equal to reflection coefficient plus theta 2, theta 1 reflection. Fine? Can I write like this? Done. Just see this. Theta 2 minus theta 1 divided by theta 1 is equal to, I'll take reflection coefficient common, 1 plus theta 2 theta 1. Okay now? I'll take reflection coefficient common, 1 plus theta 2 by theta. Then this will be theta 1 plus theta 2 divided by theta 1. And this theta 1 and this theta 1 can cancel. What will be your reflection coefficient? Where is the space? Shall I have this? Shall I have this? Shall I have? Please take note. Then reflection coefficient is equal to theta 2 minus theta 1 divided by shall I have remaining portion? Okay. See, this is your reflection coefficient. This is reflection coefficient and this is your transmission coefficient. Then if you know the reflection coefficient, can you find transmission coefficient? Shall I have this? I'll grab this entire thing. Then from 9 1 plus reflection coefficient is equal to transmission coefficient. And what is transmission coefficient? Sorry. 1 plus reflection coefficient. You do this. 1 plus theta 2, theta 1. What will be this? Theta 1 plus theta 2 plus theta 2, theta 1. This will be see, this is an equation for yes. This and this get cancelled. It is 2 theta. This is an equation for transmission coefficient and reflection coefficient. Now you tell me, we found transmission coefficient and reflection coefficient. Okay, they depend on intrinsic impedance of medium. Yes or no? By knowing the intrinsic impedance, can you find the reflection coefficient and transmission coefficient? Yes or no? No, coming to this will be known to me. What is ERM from the definition of reflection coefficient? Shall I have this? This is wait. Again, you need to write all 6 equations. That's why I kept those. What is this? ERM is Reflection coefficient into EIM. Because I know EIM, reflection coefficient multiplied by EIM will give you ERM. Similarly, this is your HR. Then what is ETM? T into see, two unknowns I found by knowing intrinsic impedance of medium 1 and medium 2. And these are the phasor form of incident, reflected and transmitted. By knowing amplitude of incident wave. You write down this again. You need to write down, is it or not? No, incidents were reflected and transmitted, they are in the form of what? Incident only. Yes or no? You need to rewrite. Don't do what I did. You want to write in time domain these 6 equations? How to write in time domain? This. They are in phasor form, a function of only space. In time domain, multiply each one by e to the power j omega t. And take a real part. For one equation, I will do it. Okay. Please take down. No, we'll study specific medium. I will take medium 1 and medium 2. Will you maintain silence? Medium 1 and medium 2, I took general mediums. No, medium 1 may be a free space or lossless dielectric. Medium 2, I will take conductor. That is one case. Second case is medium 1 and medium 2 are two different dielectric. Dielectric 1 and dielectric. Two cases I will study. But this is a general one. For examination, you need to do this general. Then specific is just deviation from here, that's all. Shall I work this? Take down. Have taken these equations. Please take down. They are equation number? No. 11, 12, 13, 14, 15, 16. First two equation change, huh? This is known to me. Wait. Her doubt is there.
You already numbered it, sir. Why are you numbering it?
Okay. Why you are number? This is again a new set term. This remains same. Okay. This remains same. Not an issue. You want to leave, you can leave. Okay, now have taken. Be fast because I want to complete that one more so that today this will complete and tomorrow will solve the problem in another 2 classes pointing my train pointing. Done? No. In above case, or in above we consider the medium 1 and medium 2 are general mediums. In above case, or in above, medium 1 and medium 2 are general mediums. In above, medium 1 and medium 2 are general medium. Now let us consider the specific mediums such that case 1, take down the case 1. 2 cases will study. Case 1, medium 1 is this is case 1. Medium 1 is lossless dielectric or free space. What is the difference between lossless dielectric and free space? Everything remains same. For free space, mu r and epsilon r is 1 for this exhaust. And medium 2 is conducting medium. This is case 1. And case 2, you write down below this case 2. Don't write above because I want to retain this. That's why I am writing this here. Case 2 is medium 1. What will be the case 2? This is dielectric medium 1 and this is dielectric medium 2. Or else free space and dielectric. Or dielectric vice versa. Okay na? This is very simple. This is a matter of 2 minutes. But this let us know. From case 2, shall I write case 2 as R normal incidence on conducting medium? Case 2. Yes or no? Medium 2 is normal incidence on conducting medium. Okay, no? Yes or no? Shall I write this? No. I want to retain still. Have you taken this heading? Medium 2 is conducting medium. Yes or no? Then what will be intrinsic impedance? Because I want to find eta 2 and eta 1 because I need to find the transmission coefficient and reflection coefficient. What is eta 2 for perfect conductor? We did intrinsic. Did we derive an expression for perfect conductor? It is something like omega mu divided by this at an angle 45. Check it this expression once. This is eta 2. Eta 1 we know it. I won't need eta 1 at present. This is eta 2. Yes or no? Yes, sir. Then from here I'll come here. Eta, see, for perfect conducting medium, what is conductivity? What is conductivity? What is conductivity? It is infinity. Then what is eta 2? If this is infinity, what is eta 2? Yes or no? Then what is transmission coefficient and what is reflection? What is transmission coefficient and what is reflection coefficient? Transmission coefficient is 0. Reflection coefficient is transmission coefficient is 0. Reflection coefficient is what? Minus 1. These are the objective questions. When wave incident on perfect conductor, the transmission coefficient and reflection coefficients values are this. Is it clear how? Eta 1 will exist, but eta 2 will become 0. Then, what about the equations? This equation will become, whether this equation will exist? Only incident and reflected. Is it or not? Shall I have this? Then incident wave. See what happens here. Whatever the wave is incident, it will be reflected back. There won't be any transmission wave. Then incident wave will combine. See, just see this. Water is flowing. Water jata hai. Then without any boundary or without any obstacle, it will move. No, suddenly you will put one obstacle. The water ऐसा move होते रहता. Whenever you put a wall or something, then it will reflect. In the beginning, some wave will be there. After some time, they will settle down. Whether any movement will be there, incident wave will combine with the reflected wave and form a standing wave. Form a standing wave. Yes, or and this is the formation of standing wave when wave incident on conducting wave. Shall we see that? I said here the incident wave combined with the reflected wave. Then what is the incident? See. Take out. Since transmission coefficient is 0, since the transmission coefficient is 0, hence transmitted wave, there won't be any transmitted wave. There won't be any transmitted wave. Next point. Since reflection coefficient will be is equal to -1. Hence incident wave is reflected completely. Hence incident wave reflected completely and combined with what is the time combined with? See, incident wave gets reflected, totally reflected, and this reflected wave combines with the incident wave to form standing wave. In medium 1, yes or no? In medium 1. Standing wave does not travel, just it stands. Standing wave does not travel, just it stands. Shall we see that standing wave? Yes? Shall I write this? Hence total electric field in medium 1 is sum of which electric field? Incident and reflected. Total electric field in medium 1 is sum of electric field of incident and reflected. Yes or no? In medium 1, this is incident and this is reflected. They combine to form standing wave. No, from that equation 1, what is this equation? E to the power minus gamma x a1. Yes or no? Is it this equation 1 plus what is ER of T? Reflection coefficient EIM of T e to the power gamma 1x ay from this equation. Okay now? Then what is reflection coefficient? Value of this? This is -1. Then what shall I take common? EIM e to the power minus gamma s minus e to the power gamma x a1. This is a vector. Is it fine? Very well, gamma 1 because it is a medium one, na? Then see, medium one is perfect dialectic. Okay. Then what is alpha? 1. Perfect dialectic है medium 1. What is alpha 1? See, gamma 1 is equal to alpha 1 plus j beta 1. What is alpha 1 for perfect dialectic? It is 0, na? Yes or no? Hence, I will write this equation as E I am. Shall I take it? I'll write it as minus because I'll adjust here. Minus EIM e to the power. I will let it be minus j beta 1. I am writing as it is. Minus e to the power j beta 1 x a1. Okay now? Is it fine? Can I write this as minus EIM e to the power j beta 1x minus e to the power j beta 1x a1. Can I write or not? Still this is in phasor form. Then, shall I write this? Then how to obtain time domain? I want you to simplify this first, then obtain time domain. This is 2 EIM. What is this? Cos beta 1x a1. Yes or no? By 2 multiply by 2. Sorry, it's not cos, it is sine. Because it's a minus. It is sine, not. If it is plus, it will be a cos.